Hello friends, how are you? Today we are going to discuss about the design pattern, most frequently asked the question in an interview. Whenever you go in an interview, most of the cases, whether you are from the .NET platform, PHP platform or Java's and something else, they ask the main first question, what is design pattern and why it is required, why they ask this question. This is the main important thing here. So design pattern is nothing, it's a just strategy how we are going to design our software, we are going to design our application. So this concept was given by four guys. So these four guys are Eric Gamma, Richard Ham, Ralph Johnson, John Wessels. So these four guys are known as Gang of Four. So design pattern concept was given by Gang of Four. Basically, they were why this thing came in light. They are doing the different type of programming, and they were stuck with different type of problems. So they given a solution, design pattern. So your problem you can resolve by using the concept. This is just a concept, nothing else. So this concept can be applied in any platform. Doesn't matter which language you are belongs from. So today I will show you the demonstration with the Java. I'll show you all the example in Java. So let's start from first. Design pattern are categorized in three. First one, actually first of all, I would like to say this video I am going to record on the special request of my two friends, Mr. Surya Bhati and Sunil. Because of them I'm shooting this video. Thanks for asking this video, Surya and Sunil. So let's start. Creational design pattern, structural design pattern and behavioral. So in creational we handle how our object can be created, how we can create our object, and structural what would be the design of our object, and behavioral how object will behave in the system. So as you can see here, the basic one is first one, prototype, and second one, singleton, builder, factory, and so on. Abstract factory. There are so many type of design patterns are here. I'll give you the code as well. You can find this code from my Git repository http github/tbarua1/ui. So I'll give you this link in code as well, in video as well. So let's start first. So first one is prototype. Why need a prototype? What is a prototype? Prototype means a fully initialized instance to be copied and cloned. Means when object is being created or copying as it is, but after copying, at the time of copy the object will be same, but after copying that object will treat as a standalone. So after that we can make the changes. So this is the main difference between copy and clone. Copying means we are just initializing the value. If I am saying x value is 5, then next time it will change to x equals to 10 maybe. So it's not a clone, it's a copy. If I am creating object of person class, and so at the time of creating object all the value will be null, and using the getter setters we can null means something what like integer would be 0, strings blank or something. So you can change these values using the getter setters class, and n number of time you can create that. But at the time of creation constructor was called. So this is just example, it's not implementation actually. So I'll show you. Let's take an example here, prototype. In prototype, let's say I have created one book. So in book, as you can see here, this book is a normal Pojo class, getter setter class, and now I want to open one bookstore. So my bookstore can have n number of books. So I need a list of books. So what I have 100 books at one store, and I have 3 stores. So 100 books are I divided into 3. But once those stores are open, book will start selling in the market. So I cannot say which user will go which shop and from where user will purchase the book. And once user will purchase the book, then book will be deducted from this shop. If shop, so at the time of copying, when owner was opening the shop, that time all books stores were having 100 books, but after that they can change their property, they will treat as a standalone. So let's see example. So this is a book having a list of books, and this is my shop. In shop I created one method, set book. So all the list of books we can put into the our shop. So all books are loaded here, and see here, this is the clone method. This is clone method. So this clone method is main acting as a functionality here. This clone method you cannot directly access from the object class. If you want to see the clone method, it's an interface. In interface, it is nothing is defined here. Nothing is defined here. And if you go in a clone, clone is the method which is defined in a system.out object class. Let's check that. Let's check that object class. Is a mistake. Okay, it's my mistake. Let's say, so this is my object class, and if you find here clone, so you can see here protected. So by default clone is method that is protected, so we cannot directly use in our class. The access modifier says protected. Outside of the package you cannot access that method. So clone is a part of lang class, lang object package. So outside of this lang package we cannot. So the solution is we have to implement clonable. So once you implement the clonable, this is the overridden method is clone. In overridden method clone, we have to create this object, and we have said this, we are getting the object. This is equals, finalize and hash code. This is all overridden method under this one. And let's check that. This is my test class. In test class, this is my bookshop. I have to create the object. Without creating object, I cannot access its property and its method and behavior. So for bookshop, I have to give a bookstore name, any bookstore name, and load the books. So whatever books we have initialized, all the books will be stored here, and I want to get all the books, get one book and remove. So if I want to sell the book, then this method I will use, and after that, once this is giving me the object of shop, and this object is being treated as a standalone, and like this, same bookshop I am going to clone. So clone, as I told you, this clone method is defined in a object class. So this method, like this, we can clone. But if you have not implemented the clone interface, then it is not possible to access this functionality. So let's see the example. How it is going on. So now we are having two different same type of objects, shopkeep one and second shop, and like this we can have a third shop. And after cloning, this object and another object will treat it as a standalone. They can perform standalone. So this is the beauty of prototype. Prototype means we are giving the copy of the initialized template object, and n number of copy it may be possible, and they will treat as a standalone. So next design pattern is singleton. What is singleton? So singleton, for prototype, you can take the example of chess game also. At the time of initialization, at the beginning of a chess game, for each and every one, the layout will be same. All the things would be as it is, whatever we have decided. But after that, both player can change its state. Both player can change their position. So this is the example of prototype. So let's start with the singleton. What is singleton and why it is required? So let's suppose singleton is nothing, it's just to prevent copy of another object. So in the per JVM, in the same one system, only one object can exist. No other can exist, no other copy of that object can exist. So let's say example, if I want to get the data from the database, so each and every time I have to create the connection. So that is not a good thing. All the time I will create a connection, but session transaction we will do later. So that's why we use a session factory in that. And real world example, you can say if if you are going to let's say example of president. In a one country only one president can have. It's not possible to have multiple presidents. And in java system dot class we can have java dot lang dot system class as having singleton example. So per jvm only one instance of this single class may be possible, not more than that, not more than that class. So how to achieve this thing, how to achieve this thing? So you have to keep in mind that we have to protect to create an object. So that is why we have to use access modifier private. So private is modifier we have to use for protecting constructor, so no one can access the create the object from outside. And next thing is that whenever we will create one static method, so it's not possible, it will take place into the memory first. So this thing can be achieved by annotation or single design pattern also. I'll show you this thing. This this is a big implementation of a spring. In a spring you can just annotate all the objects are treated as a singleton. Whenever if you want to define the scope, you can change the scope singleton, prototype, and startup, post construct, and depends on. So if your method is dependent on some other beans, so we can define that one also. So it's a good example is spring. So let's see, and this is a different type of singleton pattern. So enum type also you can use. So first let's say start singleton enum, using enum. Why we use enum? Enum is nothing to, it's a just user defined variables. Let's say I want to open a juice shop. That time I would be having some number of glasses, small glasses, medium glass, and big glass. According to the price I'll sell the juice in those glass. But user cannot ask I want 1.5 glass or something else. So to make your video to make error prone, to make error free application, enum plays a very important role here. So I have defined one instance enum, and second one is enum singleton. So this enum I have defined here is a singleton, and this one is a class. So let's say how it works. So enum, you can find the method text here also. Please read that so you can understand what it does. Enum singletons are new way to implement singleton pattern in Java by using enum with just one instance. Though singleton pattern in Java exists from long time, enum singleton are relatively new concept and in practice from Java 5. So you can see here this was introduced from Java 5. After that we are using enum keyword. Earlier it was not there. So just we created an object of instance, and we are just created a constructor. So constructor is private here, so no one can access from outside of the class. So if I call this constructor, then from outside I cannot create the object. So this method I have to use. So just new, I will use static method get instance. So this method is responsible to give you the instance. Instance equals to null. Sorry. Synchronize enum dot class. So which class is we are going to give the instance. So synchronized, you know, the synchronization is to make thread safe thing. If your thread is busy to take some other input, that time another thread will wait. Once the one thread is done, then only second thread can be execute. So you can see here. And next one, this is another example, will pushing, will push singleton. So here also what I have told you, that private constructor it should be there, and we need to define one method. Using that method always give us object of that particular class which one we want to as a singleton. So public static, this get instance always return the instance of the class. So classically most of the programmer uses this thing. So whenever user want to get the object instance, get instance, and null, if first time he or she is going to access the object, that time it will check whether it is null. If it is null, then only it will create the object, otherwise all the time the same object will return. So this is a classic singleton, and it's based on eager loading and lazy loading. This is two type of initialization. So you can see here, so this is an example of lazy loading. Whenever it is required, then only it will create an object, otherwise most of the time it will return same. And this is eager loading. In eager loading is a static factory method, and in eager loading we have to define one instance. So you can see here this line. In this line will execute, this line will take place into the JVM at the time of initialization. So whenever this class load into the JVM, that time only object will be created. So this is called eager loading. Then what is a lazy loading? And lazy loading is whenever object we require the object, then only it will create, otherwise it will not unnecessarily will place consume the space into the memory. So that's why always I'll suggest you go with this. So this is a same singleton we can achieve using reflection also. Reflection means checking data type itself. Reflection means and I would like to tell you one more important question is, if you go in interview, they ask the question, can you access one private method from the class? So is it possible? And technically I told you it's not possible according to the OOPS concept. But reflection says I will give you that access and you can access. Use this thing I tell you later. You have to get the class from that particular JVM, and internally we can change at dynamically we can change property from outside of the class. So let's come back here. Reflection singleton test, we have created this class, and eager instantiation we are calling this class. Eagerly we are going to call the instance. So this class, if you remember, I told you eagerly is going to load the object into the JVM, and after that I am going to create another object, another object of this same class, which is null. Okay, so now let's try constructor eager instance dot class dot get declared constructor. So from this class, so if you want to change something inside the object, then you have to get this thing. So we have to call that class object, and according to that we can get the particular object or constructor or whatever you want, a particular name, constructor, or annotations, whatever it is. So you can get it, and after the once you got the object, then you can change inside the value. You can change once you got the constructor, then you can change the value. You can change the name, you can change its parameter, you can change its accessible or not. So we are by default it is false. So if you want to change the property, you have to set this as a true, then only it will allow you to change its internal state. So now I am going to change its internal state. Constructor dot set name or something, and whatever we want we can change. Get object. So particular parameter or particular method we can call it. Modify parameter count annotation. So according to that we can take it. So this thing I'll tell you in next video. So let's focus on this. So if you run this program, so reflection, how it is working. So reflection means initially this object was there, and now I have another object with the copy with the object. So this is called reflection. And next one is singleton can be serialized as well. Singleton can be serialized. So for achieving this serialization, we need to only implement the serializable. So once we implement the serializable, then this thing can be persisted into the disk from JVM. Maybe disk, maybe your hard drive, maybe your database or something else. So you can persist, and rest of the things are same. We are not going to do any other thing here. So only we have to implement a serializable. So this is also another example of singleton. In singleton, the same thing we are going to access that. So here you can see I created some parameters, some variables, and this is constructor is protected, so outside of the package it cannot be accessible. And this is the method. This is what story I am telling you since beginning. So first we are checking whether it's null or not. If it is null, then it will give you the object on the basis of thread. So this is main important. If you are going to program high level programming, that time it would be very useful. So you can see here, if it is going to check whether it's first thread. If it is false, then it will sleep, and next one will create. Let's see. Next one is singleton initializer. Here is nothing. I am just getting a copy of that object, nothing else. serializable test. This is the main class of serializable class. In here, I'm why I implemented, I told you that if I want to write or persist the object from JVM to in some file, that time we need to implement serializable. So public static void main, I'm going to create object of serializer instance, and it will give us instance of that, and object output we are getting, and this output I am going to write in a file. File name would be file name dot serialize, or you can give some other name like hello dot test or anything else. So whatever you want to give name, you can give. Then from that file we have to fetch the object. So like this we are going to write the object into the file. So and now that stream is closed, output stream is closed, and from file we are going to read that. We are going to read the object, and from file we will give it will give us object from file, and object we can read and we can write its hash code. Hash code is nothing, it's just a dynamic generated number. In the next video I'll tell you the hash code as well. Let's see the example. So this, I'll show you this file, what is written in that. So here is the file. My system is a little bit slow. Design pattern out, you can see that this is the file name where we have written the object. So if you want to see this, nothing will come here, it's just a binary file. If you are a window user, you can use this thing in Windows as well. So this is my text editor. In text editor I am going to open this. So this is something like this, it will return. So we can persist our object in this the same way. We can write our object into the database as well. So that is why if you noticed, if you are programming for Hibernate or something else, or like SQLite, then we have to implement the serializable, then only it can be written in a storage. So let's say another example of singleton is still singleton. Different example I'm showing you, because this singleton, most of the interviewer asked this question. So I don't want to take I want to make you very strong in terms of the concept. The same thing I'm doing again, singleton, how to do that. So this is my classical singleton. I created object, and I created this one object, and this is my logger class, and public singleton I created this method. The method means constructor, it's a constructor for me, and it will call the test cases. So this is a part of test cases, like if you want to test your unit testing. So there are two ways to test the unit testing. Either you can use @ annotation, or you can use test cases. So I'll show you another example as well. You can see here my test is passed now. Text is passed now. @test. This will also do the same job. I don't have a JUnit library, that's why it's not working. I have to download the library, JUnit library, then only it will work. By default it will give, in my case it's a particular library is not available, that's why. If you can try this same example in your system, and 100% it will work. So you can see here my test cases set up. So in next video I'll tell you the JUnit as well, so we can set up before testing. So leave it at this example for time being. So this is a test being assertion and all. Yes, and see this, have a focus on this folder. So this, in this example I created this class static block. So you know the static keyword creates a change the behavior of the object. It takes place into the memory first whenever it's loaded into the JVM. So I have declared this particular block as a static, so at the time of loading class it will be stored there. So like this we can get it, the object all the time, but this is not good practice. Always I'll suggest you go with the lazy loading. Lazy loading is good one. This example you can find from my Git repository. My Git repository is github/tbarwa1/uy. So this is my Git repository. You can download all the including Android or study material, whatever you need, you can download examples. So now I'm giving you the sample of design pattern. So these design patterns are available here. So creational, structure, behavioral. So this is our singleton example you can find. Okay, so this is our URL. So visit our URL, you can find from there. Okay, let's come back. I think this is also test case. It's a part of JUnit. JUnit I'll cover in next phase. This is also past test phase result. And see this, like this also we can achieve the we created a class thread safe singleton. So there are two type of we can create a singleton class, thread safe or not thread safe. So as I told you, lazy loading or eager loading, that those are not thread safe. This is thread safe. Once we have created object, all the time it will be exist in the system without interacting with some other. And now see, so constructor is private again, and this is the method which is synchronized. If some other some other method is some other thread is going to access that time it will not access. So that's why you can see here method is synchronized. So instance, and we are going to create the instance if it is not null, otherwise most of the time it will give you the instance. And thread safe singleton. So like this we can achieve that singleton. So singleton is done for today. And next one is, as I told you, I'll let you know each and everything. Second one, third one is builder. Let's focus on a builder. Why builder class? So let's see builder. Builder is nothing, is provide you the option to create object as per user's requirement, not the default system. If user not giving any preference, then it will give a default system. Like you want to create one phone, then you will go to the factory and ask, I want a phone. So they will give you an ordinary phone. But if you say, I want customized phone, then according to that they will give you the customized phone. And if you go, real life example is, if you go in a party, there are drinks are there available, starter are there, desserts are there. So each and every options are available, but whatever you want you can choose according to your requirement. Otherwise everything is there. So let's see. This is my phone class. This is a normal Pojo class, nothing else I am doing here. So in Pojo class, string OS, which OS I want, which processor I want, what would be the screen size, what would be the battery, what would be the camera. So this is my constructor. Using constructor I can put the value inside that, or this is my getter setter. So I want some customized object of this phone class, customized object of the phone class. So we need to create one phone builder. In phone builder is nothing, it's also another type of getter setter class, but it will not return you the plain thing, it will return you the object of the same class. So let's have a look here. So inside this we are having same parameters, and we created this constructor, and this constructor is going to return me a phone, default phone. It's a default phone. If I'm going to call the phone builder dot get phone, so it will give me this one. Whatever the property of this builder having, it will return me the phone. And once we are having the phone, so this is my constructor, another constructor, this is my another constructor. I can put the value inside that, and these are my getter setters. And in generally earlier we are going to access that get OS, it's going to return the OS. Set OS, I'm putting the string and I'm saving the data, but I'm returning object of the same class. So as a return type as a phone builder. So if I want to access again, I can change the value. You can see same here, I am returning this. Okay, now let's run this program. Do not forget, I have written each and every program some comments. Do not forget to read them. This pattern is introduced to solve the some of the problem with the factory and abstract factory design pattern. When object contains a lot of attributes, builder pattern solve the issue with a large number of optional parameters and inconsistent state by providing a way to build the object step by step and provide a method that will actually return the final object. So this is my builder class. I'm creating object of builder class, so it will return me the object of, you can see here. So what is going to return me? it is going to return me the super. And once we are having that phone builder, we can set the property. And property for what? Battery I want 3000 mAh, and I want Android OS. So once builder is done, then I can ask give me my phone. So using this I can get the phone. Let's run. So this is my object, and next time I want to change something, let's say Windows phone, my mistake, and I want 2000 mAh battery. Let's see, I can change each and everything from here itself, but all the things are null. If I want to put something else, I can say screen size should be 1080 p. It should be. This is my mistake. Okay, let's change that. Let's see what happens. So you can see I can put that now. So this is builder class. Builder design pattern. Next one is factory. So it's a very similar to the factory and builder. Both are little bit similar, but not completely. Builder was giving you the option to create the customized phone, but it will but the factory says don't bother about anything, I'll take care of all the things. Let's say I created one operating OS is an interface. Using interface I have implemented iOS. I have given iOS specification, and Android I have given Android specification. I have given Windows specification, and this is my factory class. So what if I want to get the particular phone, and according to that object it will return. So you can see if I write open, then it will return me the object of Android. If I write close, then it will return me the object of iOS. Also it will return me the object of Windows. So let's see example. Please do not forget to read this comment. These comments will help you to learn more. So in this way I'm going to write factory and just call that, and I'm getting the instance of OS and specification it will come. If I change the Android, so object internal state will be changed. No, I have to write open, not Android. Most popular OS. So according to that we can check. If I write closed, so internal state is going to change directly. So you can see here. So now Another is abstract factory. Abstract factory is nothing, is just implementation of abstract class. In the factory method we have used interface, but in abstract factory in the same place we will use abstract class. So let's see example of abstract class. It's about internal functionality also same. So I created two interface. This is the interface and this is another interface, and both interfaces are controlled by one abstract class. Color interface implemented with a blue color. I have given a blue color is things. I have given a circle things. I have given a color factory. Color factory is a color factory is the class implementation of abstract factory. This is the implementation of abstract factory. You can see I extended with the abstract factory, and this is always give me the object of color. Color may be red, green, blue, and so on. And this is a factory of producer shapes. What kind of shape I want? Color. So it will always return me the color, otherwise it will return me null. So you can see here green color implementation, rectangle, red color, shapes, and this is shape factory. So what this is also extended with the same abstract factory class. So this is abstract factory class is working as a front controller. So you can see here it is going to return me the color, which color I want. It is going to return me, and if I am directly using that, it will return me null object of the color, or it will return only shape. Shape may be circle, rectangle, and square. So you can see here. So let's see what is the implementation here. It is nothing, it's just an abstract class, and both two methods are declared here. Let's see the example. See, again I am notifying you, please do not forget to read this thing. Abstract factory pattern is similar to the factory pattern, and it's a factory of factories. Multiple factories we can implement, extend, but in factory method we can implement. If you are familiar with the factory design pattern in Java, you will notice that we have a single factory class that returns the different subclasses based on the input provided, and factory class use if, else, or switch statement to achieve this. In abstract factory method pattern, we get rid of it else block and have a factory class of each subclass, and then an abstract factory class that will return the subclass based on the input factory class. So you can see here, this is my public static void main class here. So I'm calling the abstract factory, and abstract factory is responsible to give the object. So in abstract factory we are having two objects, two methods we have defined here. So I want to get factory. So it will give me the shape, and shape maybe type of whatever shape is going to return, and that shape we can circle, rectangle, and here is the color factory. From color factory it will give you the object, and we can change which color I want, and finally which color to be filled. So let's see what is the output here. So you can see inside the color circle draw, I am inside the color, inside the rectangle draw, rectangle going to draw, and inside the draw square, fill red color and green color and blue color. So I am not directly accessing them. It's a factory method, so it's giving me the object directly from this system. So this is an abstract factory class. You can take this is also another example of abstract factory class. I want to take a loan. So if a loan percentage for different companies, different banks may be different. So this is my abstract factory class. I want to get bank, so it will give me the object of the bank, and it will give me the loan from which bank I want. So this is my bank is the interface, senior interface. So it will give me the get bank name. Bank factory is a extended to abstract factory. So it will be we have to implement that. So if I want to give a HDFC bank, so HDFC bank will give me the object of HDFC. If I pass ICICI, then it will give me the object of ICICI. If I give SBI, then it will give me the object of SBI. Otherwise it will return me the null. So particular loan will be provided. And if without this creating object, I am directly trying to take a loan, then it will give me the null object. So implement the perfect model view control here. So business loan, and extend to the loan. Loan is a abstract class. In a abstract class, we have a particular rate, and each and every bank having a different rate of interest, and based on the rate of interest we have to calculate that. So you can see here rate is defined as a protected. So whatever rate is defined for particular HDFC bank or something else other bank, then you can write here directly. So directly it will come from there. So EMI will be calculated on the behalf of rate. Rate is coming from loan class, particular bank class. So this is my bank factory. This is a business loan. I want a business loan. So it will for business loan rate of interest would be different. And this is education loan. This is a main factory creator. So this is a main factory creator. This will provide me the bank factory, and this is a loan factory. First we have to get the object of bank, from which bank we want to loan, and how much loan I want. So let's see the HDFC bank. HDFC bank implements bank interface. For bank interface we are having particular bank name, and bank name returns the particular bank name. Home loan is extend to the loan, and get extend with the rate of particular rate, whatever rate we are going to give, because this is a part of home loan. ICICI, for ICICI same as HDFC bank. This is my loan class. A loan would be calculated here, but based on the particular one. So you can see this is we can write abstract and non-abstract method. This is my loan factory. In loan factory I'm getting the bank name and get the bank loan, which type of loan I want: home loan, business loan, education loan, particular loan I can take. This is my PNB bank. If I write like this, then this is my SBI bank, State Bank of India, Yes Bank. Let's run our program. This is buffer reader. Enter the name of the bank. Loan I want 10,000, and Rate of interest is 6.5. Enter the loan amount you want to take. Okay, enter the number of years. For how many years? I want for 2 years. Null pointer exception, which location? Okay, so it's going to null pointer. Why it is coming null pointer? Because maybe problem with the calculator. It's not initialized. Let's run this program now. So loan amount, I'll say SBI. Enter their loan, type of loan, education loan, education. Rate of interest 6.5, and enter the loan which you want to take, 30,000. Enter the number of years to pay. I take for 2 years, and so EMI is calculated, 1,336. So this was the problem. So factory is done. Object pool, yes, object pool. Object pool is another type of design pattern which is used for long running task. So let's assume we want to run the task for so many years, so many months, so many days. So in that case we will use that. We have to pool the objects into the memory for a long time. But directly if we do this thing, this is not a good thing, because thread safety we have to take care. Thread safety comes first. So mostly performance is the key issue during the software development and the object creation, which may be costly step. Object pool pattern says that to reuse the object and expense to create. Object reusability we are going to implement. Basically, an object pool is an container which contains a specified amount of objects. When an object is taken from the pool, it is not available in the pool until it is pulled back. Objects in the pool have a life cycle: creation, validation, and destroy. You can take example of JVM. In JVM we are having garbage collector. We are going to create the object using the constructor. So this is a small example, but this is good one. I'm going to show you. A pool helps to manage available resource in a better way. There are many using example, especially in application server. There are data source pool, thread pool. So particular group of pools. We can take the object, we can put the object. So let's see how we can achieve this. First, we have created one class. Class name is exporting process. So this is class is responsible to export the process. N number of object process we can put it into the system, and exporting the process. You can see here. So this is the constructor. Process number ID, process ID we have to provide by the thread. So there is some number is given by the thread as well. So this is my exporting task. So that was related to the particular thread. and this is complete task. In one task can have multiple classes of processes. So this is a thread. So most of the process are implemented on a single thread. That's why you can see here it's a runnable. It's a runnable. We have implemented a runnable to create the thread. And now these are the instance variable. We have created the instance pool. At the time of loading class into JVM, it will be initialized as a null or default value. Default value is null. So this is a constructor. If I want to put all the objects directly into the system, we can put on how many number of threads we want to put. So implementation of thread, we have to put the implementation of run class, run method, importing process is borrow object. I'm going to pull the object from the system, and I'm going to pull the system object from the system, export. And this is the object pool. This is a container. Actually the object pool is a container. In container you can see here I have passed t means n type of objects can be put, thread based. So thread based object we can put it here. So this is the instance variable. We have schedule executor, and this is abstract class, abstract keyword of object, create object. And now initialize that object. We have to create the object, n number of objects. Create object, we have to add into the pool. We are creating a pool, and once this thing is initialized, this is the constructor we are created, constructor. And this is another parameterized constructor. We can use this one, and we are putting all the objects into the system, and we are creating object into the system, and it's done. We can pull the object, we can put the objects. Let's see example. So this is the class type of exporting process. We can export the process. So this is an instance variable we have created here, and this public static void main is a very simple one. I'm creating object of this test class and going to set up, then tear down and test object pool. So this is a long running task. So you can see here object 1 is created, object 2 is created, object 3 is created, object 4 is created. So all the object in the system. After that, each and every thread 1 object with the process ID 1 is borrowed, and it's a return. And this one is borrowed and return, this one is borrowed and return. So finally in this pool we don't have anything here, so finally pool is empty. So this is a long running task. If I want to implement like this, we can do. So that's it for today, and next video I'll show you the things related to the behavioral and